Welcome everyone. In the previous video, we have seen how to find the Thevenin equivalent of a circuit. So we are going to solve the same problem, but here we are going to find the Norton's equivalent. Now, what is Norton equivalent? Let's discuss that first. As you have seen, in case of Thevenin equivalent, we are representing the circuit in terms of a voltage source and a resistance in series. So this is our Thevenin equivalent, VTh, and this will be RTh. But in case of Norton's equivalent, we are going to represent the circuit with a current source and a resistance in parallel. This will be our current IN, and you can write this as RN. Okay, so how to find this IN and RN? To find the RN, you have to use the same method as we have done in case of RTh, which is the Thevenin resistance. And the steps are this. So first you have to remove the voltage and current source. How? A voltage source you will do short circuit, and the current source you have to do open circuit. Then if there is a dependent source, do not change that. Then connect a voltage or current source at the output terminal. Then find voltage and current at the terminal, and you can find the resistance. If you want to see the solution, you can check on the previous video. Here I am not doing it again. So this was the solution. If you want to, you can pause the video here, you can check the calculation. Alright, so now coming back to the problem. So we have found that the resistance Rn will be 10 ohm. Okay, so let's keep it aside and let's find the IN. Now how to find the IN? So we have the circuit like this. Here we have 9 volt, 2 ohm, and there is 3 ohm, and the terminal is here, and like this is A, B, and there is a source, dependent source, which is V A B by 4. To find the current IN, so basically we have to short circuit this A and B terminal, and whatever the current will flow in this terminal, that will be your current IN. Alright, so now let's see. When you short circuit this A and B, the voltage VAB will become 0, right? So this current source that's in the middle, VAB by 4, that also will be 0. So basically we can say that this current source is supplying a current of 0 ampere, or basically you can assume it's a open circuit. So just remove this current source. Okay, now you've got a simple circuit and you can easily find the current. How? Use the KVL, or directly you can just use V by R. So the voltage is 9 and the resistance in the circuit is 2 plus 3, that will be 9 by 5, and that will give you 1.8 ampere. Okay, so we can represent the circuit, I mean this circuit, how? A current source like this and a resistance in parallel. So this is A, B, current is 1.8 ampere and resistance is 10 ohm. So this is our final Norton's equivalent. You can also find the Norton's equivalent from the Thevenin equivalent. By how? By using source transformation. The Thevenin voltage was VTh is 18 volt and the Thevenin resistance was RTh 10 ohm, right? So you can see here, if I do V by R, you will get the current is equal to 18 by 10, that will be 1.8 amps. So basically when you have a voltage source and a resistance like this, you can convert this to a current source and a resistance in parallel using this method. Okay, so if this is VTH, this is RTH, this will be IN, this will be RN. So here RN is equal to RTH, no problem, and IN will be equal to VTH by RTH. You can use this method also to find the Norton's equivalent if necessary. But in the exam, if it is asked to find the Norton's equivalent, you have to use this specific method only. You cannot use Thevenin equivalent and then use source transformation to find the Norton's equivalent. Alright, I hope this is clear to you. Now we will discuss it further in another video with some more difficult problems. Okay, so if you have any more questions, please ask in the comment section. Thank you.